Hi, Jorge. Yeah, tell us a few words about yourself and about the tool you want to show us.
Well, my name is Jorge Torres. I'm the CEO at MindsDB, and we are an open source company that is producing the open source alternative to Google BigQuery ML, if you want to see a parallel. And maybe the best way to explain you the journey of MindsDB is if I share some slides. So I'm going to do that in a second. MindsDB brings these machine learning capabilities to databases because we believe that applied machine learning can be simplified if you bring machine learning to the database rather than the other way around, trying to get data to the model. And in the modern terms, we try to do a data-centric approach to machine learning. We believe that when you're trying to apply techniques is probably the one that will reduce the least amount of steps. MindsDB, a little bit about us. We started this project at UC Berkeley in 2018. And then we went to Y Combinator in 2020. We were one of the most promising AI companies by Forbes last year. And we've raised $7.8 million in seed rounds funding up until now. This year, we made it to the Gartner Cool Vendor Matrix, and we have a very strong open source project, more than 8,000 GitHub stars, a very fast growing Slack community. And people love us because of the simplification that we brought to the table of MLOps lifecycle. And before I jump into that, it makes sense to kind of discuss the MLOps lifecycle. You have essentially three main blocks. You have preparation, modeling, and deployment. And for data preparation, we believe that a lot of this, if not all of it, can be done at the data layer or in the database. And this is not the way that people do it today. People today do data preparation and modeling in the same stage. They tend to kind of carry a lot of the way that they do machine learning when they do their PhD thesis or how they learn it through Coursera or anything. They carry the same, it's a research project. And yes, it is, but it is also an applied project. So you want to apply this thing. And therefore, the way that is being done today in pandas and massaging data in pandas may not be the most effective way for you to eventually make it into production. And the problem with that is that once you have a Panda script, then you have to productionize this, and you end up incorporating extra tools for this. You end up incorporating ETLing into the mix, so you can now run your Panda script, so you can transform the data that is actually coming from a database down into wherever you deploy your ML model. You also have to provide a whole bunch of infrastructure to host your machine learning models, and then to get the predictions back out to where you need them, either into the application or the data warehouse. So there's a lot of piping that you have to do. And at the end, you end up doing more work that has nothing to do with machine learning, just to get it all to work. Now, when we start to review this, we start to realize that, I mean, databases in itself have been built for such a long time that the data preparation side can be solved with them. At the end, when you run a SQL query, you get a table. Whatever columns you have in that query are features to a machine learning model. And databases have been designed for more than 20 years to actually do data preparation and data transformations in a way that maybe is more effective than what someone can write in pandas. And no matter what problem you have, you will always find a database that will do it very well. So if your problem is time series, you will find a time series database that specializes on this type of transformations. If your problem is big data, you will find like data warehouses, data lakes that can do it with a very decent performance, much better than perhaps the performance that you can put together into some Python scripts. So the moral of the story for us is data preparation. If you use a database, that is solved. You know, the data preparation has been solved by databases for a long time. They've solved it for many other use cases other than machine learning, and they can solve it for machine learning too. Then we thought, okay, modeling and deployment, what if we find a way to simplify this, you know, in a similar way that any user that has a database feels related to? And we thought, why don't we allow people to create and manage machine learning models through SQL? At the end, SQL is such a powerful language, and a language that is intuitive to many people that already do analytics, that it made sense for us to do it. So the trick for us here was to create this concept called AI tables. And AI tables actually simplify the game for many people. And let me walk you through like some basic intuition, and then we'll jump into a demo. Imagine that you have a simple table, income and debt, yeah? And if you were to visualize this table on the right-hand side, you actually see these data points. Now, databases are designed to give you a response so long you hit a record that exists in the database, or you hit an index. So say, for instance, if you query this table for when income is 80,000, you get a response, or you get like a result. But if you query for data that is somewhere in between, even if it's very close to some data points, databases are not designed to either interpolate or extrapolate, and therefore you get nothing. Now, you can build a machine learning model. In this case, it will be a line that you will fit to the data that you have. And this is very cool because these models at the end are just an extension of the data, or like a generalization of the data that you have. And what we thought was, why don't we create a syntax that allows you to create this model in a very simple and SQL-like form, similar to how you create a view. So you say create predictor, you give it the name of the predictor, and then you train from whatever table you want. That could be also a query, train from select, and then you can do whatever transformation you want to do in the database, and then what columns you want to predict. And then you can also specify from there what is that you want the model to be, if you're dangerous enough to do that, or if you actually want to kind of tweak the machine learning parts in a declarative approach. Now, once you do that, now you can query this line, or in this case, I mean, if it's a model that is multivariate and you have hyperplane, etc. But at the end, you can query anywhere within that surface, and you can get responses that are an estimate or an approximation to what it can be. So in this case, if you ask the model, which are asking these questions in the same way that you ask to a table, you can get a response for what would it be when the income is 90,120, and then you get that approximation. Now, let's jump into an actual example that we can run through a demo. And in this particular demo, we're going to forecast real estate prices for properties in Berkeley. And the first thing that you do on MindsDB is you can plug a whole bunch of different data sources to MindsDB. MindsDB already supports the most prominent databases that exist, and we partner with all of them. And for this particular demo, we're going to do it in a Postgres database. We're going to connect to a demo dataset that we have here. Now, MindsDB allows you to bring databases in the same concept of external databases that ClickHouse has. So you create a database, and then that database actually doesn't live inside MindsDB, it lives somewhere else. In this case, we're going to point it to a Postgres database that has like this connection settings. Here we have some demo data sets, and we'll explore them in a little bit. But the one that we're going to look at is called the real estate demo data. So let's look at that. Now, in this one, we have a simple table that has information about properties in Berkeley, as I was telling you, where you have the number of rooms, number of bathrooms, square footage, location, days on market. And at the end, what we want to forecast is the rental price. We want to forecast the rental price for the minimal number of days in market. So you essentially, if your input is 1 or 2 days, then it will give you what will be the most approximate rental price for a given property. The way that we do this, and the way that we simplify machine learning in one single statement, is like this one. So you're saying, oh, I want to create a predictor. I want to name this predictor home rentals model. And the data preparation query will be this one. Again, if your data was all crazy and you needed to do more transformations, MindsDB allows you to delegate as much power to the database underneath, in this case, Postgres. So it can be any query. You can say, okay, I want to learn from any query that I have here, and on the result of that query, I would like to predict rental price. Let's create this predictor. Now, the cool thing about doing this in the data layer, or doing it in this kind of syntax, is that data preparation happens here. Model generation is essentially where you pass here. You can specify what model you want as well. And then deployment is instantaneous. As soon as you do create predictor, it has the same consequence that you will have when you create a table or a view. The view may take some time to materialize. It's the same thing that the predictor may take some time to train. But as soon as it's done training, you can consume this model straight without having to think of, oh, how later are you going to deploy it or not? So let's look at the model and see how it's going. This may take a little bit. Actually, it's already done. So once you train a model, you can inspect what is it that the machine learning did. So MindsDB comes with this statement called describe, and then you say, I want to describe this particular model. And tell you, okay, the model is done training. It used an R square function for validating the accuracy. Is very accurate to predict the rental price. If you want to see what the actual model looked like or what it picked for the model, you can say that model, and it tells you, okay, for this particular example, I tried a neural network, LightGBM, and a linear regression. The one that performed the best was LightGBM, and that's the one that it selected. You can see even how the ensemble of the model was.
I'm quite curious what actually happens when you execute this, when you create a predictor. So you have an instance of MindsDB, and then you have an instance of Postgres. So MindsDB pulls the data from Postgres, you train a model there, right? All the data preparation, of course, happens on Postgres. You just get the result set, right? And then you train a model, and then you save the model in MindsDB. Is this how it works?
Yeah, this is how it works. So you can think of MindsDB as a database of machine learning models, and therefore it portrays model tables. And then, yes, the data stays where it lives, in this case, Postgres. And MindsDB only pulls that data by like whatever query you define that you're going to learn from. And then if it's a time series model, it will also be smart enough to understand, okay, whenever you make a prediction, it needs to go and pull data from the last n readings that you have on the database for that specific prediction that you want to make. But at the end, it leverages as much as possible on the database. When it comes to the model is stored in the MindsDB cluster, and then it gets invoked every time you actually do a select from that model. But let me actually tell you something deeper as to what is happening as well. When you did this create predictor statement, the one that we have here, actually what MindsDB did is, let's evaluate the data that we have and encode each of the columns that we had on the input, so that we can actually treat them or as vectors in a machine learning model. So it will look at rental price, it understands as a numeric variable, so it will automatically pick a numeric encoder. It looked at number of rooms, and then it said, well, number of rooms, even though it's a number, is more like a category. You have a specific number of rooms, and then beyond that is just, you won't have like houses that have 100 or 20 or 30 number of rooms. So for this one, it picked an autoencoder that is one hot encoder. Now, if you wanted to change this, you can modify that statement on the create predictor and say using encoder for number of bathrooms, and then you can say numeric. Then the same thing did for number of bathroom. For the square footage, it's actually numeric. For location, again, is a category, so one hot encoders. And essentially is trying to go through all the different inputs that you have and pick what is the best way to turn that into like a vector that you can deal with. And then at the end, it says, well, for the model, I'm not going to kind of pick one per se. I'm going to actually send a few ones. I'm going to say a neural network, LightGBM and regression, and then pick the best of that. And then at the end, that is the model. Now, once it's done doing that, which we've already seen here, it's done training. This can be queried the same way that you query a table. So let's run a simple query. So here we're saying, okay, let's query this model as if it was a table. Let's see what will be the rental price and give me an explanation of that prediction that you're going to give me. For a property that has a square footage of 823, it has location good, and it's in downtown, and you want it to be, 10 days of market at the most. Let's run this query. So what MindsDB gets here is, okay, for this particular property, the estimated price is 4,394. I think that if you've been to Berkeley, it seems reasonable for an 823 square footage. Now, what it's also telling you is, look, the predicted value is this one, but there's a confidence and a confidence interval. So it's saying the lower bound is 4,313, and the higher bound is 4,400, and it has 99% certainty that it will land somewhere between that. This data that you're passing is not anomalous. So if you were to give it some crazy queries, it will flag it as you don't have data that looks like this. But essentially, this is what MindsDB does for you. It allows you to, in very simple steps, you can connect it to your data source, and then it allows you to create a predictor in a way that is very similar to creating a view. And then from there, you can start consuming these predictors the same way that you consume a model. It's pretty cool because then you can do things like joining predictors with data you have, which is kind of like the most common use case that people may have, where you want to make predictions in bulk. So what you're saying here is, you know what, I want to join the model with data that I have, which is a home rentals data. And I want to be able to get the real and the predicted price so I can get a comparison of how the model performed. Like actually I want to visualize this. And let's look at this. Here you can see that it is actually getting pretty good at predicting this. The real value is 3,900. It predicts 3,800, 2,042, and predicts 2007. So it can give you a good overview of how the model is actually working in general. And then you can do this for, say, for instance, assume that you don't have properties where you have the real price. You can put it here in the query where real price equals null and things like that. Anyway, that's in a nutshell what MindsDB does for you. I invite everyone that is watching this to go and see our open source project, as well as try the cloud version if you want to get started really quick. And the whole idea behind MindsDB was to ensure that as many people as possible that have data already sitting in a database could actually make predictions with the least amount of steps.
Mm-hmm. And if I want to run it locally, do you have some sort of Docker compose that I can just run? How do I test it locally?
Yeah, absolutely. Okay. So if you go to docs@mindsdb.com, there will be a whole bunch of different steps and settings that you can set up yourself, or like different environments. You can deploy this either through Docker or directly from source. MindsDB right now has accomplished what we know as open source maturity. So it is a very simple product in the sense of you will find documentation for most of things, problems that you have. The community is there to answer any questions. And essentially at this point, we're getting to the next stage of MindsDB, which is enabling the community to build more and more integrations. So for that, and if you're a developer, we're looking for people that want to contribute. And we've made it very simple to the point that this month alone, there's like 25 ideas of integrations that we never even thought of, and people will start, are starting to contribute in that sense.
Mm-hmm. Yeah, I guess I see a clear use case for batch scoring. So when you have a model, and let's say we want to train this model and then apply this model regularly every day, right? So then we can just keep everything in the database. But what if we have an online case? What if we want to deploy our model as a web service? Is there an easy way to do this? I guess maybe export this light GBM model and then put it in Flask or something like this.
Yeah, you can definitely do that now, even with MindsDB. So all those models you can complete from a RESTful API endpoint as well. And you can connect to, there's also a RESTful API for sending queries directly. Mm-hmm. Not necessarily that you have to connect to.
Mm-hmm. So I don't even need to pull the model out of the MindsDB. I can just click a button, create REST API, and then I would just have it in an endpoint, right?
Yeah, yeah.
That's pretty cool. Okay. And I've heard you also have an integration with MLflow. Maybe can you say a few words about this? I'm really curious, like how it works.
Yeah. So say for instance, and the reason why we did the integration with MLflow, imagine that you have DBT, for example, and you're transforming data into your data warehouse, and you want to enrich data with predictions. Imagine that you're an online retail store and you have comments about all your products, and before people start doing analytics on the data warehouse, you want to get some sentiment prediction of what comments people have on your products. So MindsDB allows you to now bring a model that say you didn't develop through MindsDB, but you develop an MLflow that is a sentiment analysis model. It takes some text in, and then out it gives you the sentiment. MindsDB integrates with MLflow in a way that any model that you have in MLflow looks like a table for MindsDB. And then since you can connect to MindsDB from any MySQL client on a MySQL compatible tool, such as DBT, we have an integration even with DBT that kind of leverage on the MySQL protocol. Then you can say, okay, connect to MindsDB, join the data that they have for all the different products with the sentiment model, and then get another column with the actual sentiment and store that into the data warehouse. That's something that you couldn't do directly from DBT if your model is in MLflow, unless MindsDB is in the picture. So that is one. The other one is, let's say you're already in Tableau and you want to get the sentiment without having to do the DBT part. So you can connect to MindsDB from Tableau, and then you can join, again, the table that has all the comments from the people with the model that you had in MLflow, and get the sentiment, and then now get your average about like what is the sentiment of product, et cetera, et cetera. So when I'm saying that we integrate with Tableau, with MLflow, we integrate with the capability that MLflow has to deploy models behind a RESTful API. And now what we do is, okay, now you can query those models using SQL, And since MindsDB is already compatible with a whole bunch of tools up the stack, then you can query those models in the same way that you query a table.
Okay, so the integration with MLflow is, let's say we trained a model using the usual approach. We deployed it, not deployed, we use the model registry in MLflow. We say, okay, this is the model in production, and then we can pull this model from the model registry of MLflow, put it inside MindsDB, and then score whatever records we have in the database. Is it right?
That's correct. Yeah.
Okay, cool.
Not whatever records. I mean, it will expose the model as if it was a table in the database. You can query that model. So you select from that model that is hosted in MLflow, and then whatever you have in the where statement is transformed as input to the model through the RESTful API. When you get a result, it formats that as if it was a table. So now you can query this from the SQL layer without having to write any infrastructure to connect it. And again, this is useful if the tools that you have can connect to a database, but not necessarily to a RESTful API endpoint.
Mm-hmm. Understand? Yeah, pretty cool. How many people are? Yeah, I still remember at the beginning you show a picture. So I'm wondering how many people are actually working on this. More than 20, right? On that picture there were quite a few people.
Yeah, 22 people. Yeah.
22. That's impressive. So what are your plans? What do you want to do next?
Yeah, I think that right now the plan for MindsDB is to continue to incentivize community to write more integrations. At the end, the more integrations that MindsDB has, the more you can buy into the idea that people don't have just one tool in the data stack. Machine learning is a cross-stack problem. So you may have your data in MariaDB, you may want to train from that data, but you may actually want to enrich data that you have on Snowflake. And then you may actually want to be able to mix that data with other models that you may have up at the BI tool, or you may want to deploy them into a stream so that you can do real-time predictions. And the fact that MindsDB integrates with so many of these tools allows you to do this kind of cross-dimensional machine learning or end-to-end machine learning. So what is next for MindsDB is going from the 15 integrations that we have to probably 50, 60. Now, a lot of data and a lot of databases are not traditional, relational databases. We integrate now with document store, kind of like Mongo, etc. But there are integrations on the pipes for people that have data for systems that have an API behind. So say, for instance, you're a Shopify user and you want to do machine learning directly on Shopify data, but you don't want to do the ETLing. You don't want to extract through an ETL tool, put in the data warehouse, and then do machine learning. This type of integrations are very interesting to us because for us, those are databases nonetheless. It's just that you query them through an endpoint that is an API. Nonetheless, these abstractions allow you to now portray the basic collections that you have for the basic objects that exist behind the API as tables. And then you can do all the machine learning part on top of them without having to do the ETL. So that's Shopify, Bento, yeah.
So basically, the end user will still use SQL, but under the hood, you will convert this into GraphQL or whatever language that you use for communicating with the backend. You will send this request, get some data, and then apply the model and give the results back to the user. That's pretty cool.
Exactly.
Do you have any advice for anyone who is watching this? Any kind of advice?
I have advice for people that want to build an open source project. I think that it is the best way to build software. If you have an idea and you want to pursue like a different angle to a problem, I believe that open source is the best angle at getting something out there and getting feedback really quick. People will give you feedback mostly because they don't even have to pay, but a lot of people want to try new things. And there's something beautiful about the community angle of open source. It just becomes bigger than you and the team that are building this. And at the end, you turn it more into a mission. And the case of MindsDB is trying to make it very easy for people to do machine learning without having the requirement of having a PhD in mathematics and things like that. And then being able to actually use the data that you have. And I feel that when you do it in the open source route, you find a group of individuals that buy into that same mission and vision, and it's just super powerful. The other advice that I were to give to individuals is when you're trying to build a tool like this one, there are a lot of biases that you have into what you believe is a problem. And the earlier you can find a mechanism to understand that maybe the approach that you've taken requires more input than you are comfortable taking, then the better. I think that it has taken us time to really understand that getting input from the community was crucial for the development of the product itself. So I believe that, you know, customer-centric or user-centric development is crucial.
Yeah, and I fully agree. Open source is really cool. That's why I really enjoy talking to authors who do everything in open source. That's really cool. Thanks for doing this, and thanks for doing the demo. Amazing product. Thanks for telling us about this. And anyone who is watching, please, if you haven't done so already, please give MindsDB a star. So we will include all the links and give them a try as well. So pretty cool project. Thanks.
Thank you, okay. Looking forward to see it. And again, thank you for the opportunity to be here.